Good afternoon, my dear participants. I, Vedantya from MLRIT, Assistant Professor. I'm just welcoming you all to the day 5 afternoon session online with Kumar Dash is currently working as an Assistant Professor in the Department of Computer Science and Engineering at National Institute of Technology in Mizoram. He holds a PhD in the field of more than 12 years of experience as a faculty. He is also a supervising more than 10 specialized in natural language processing with machine learning techniques. Currently, he has two ongoing research projects sponsored by EIHIMP Bihali, for which he is also a joint director of two startup firms. Earlier, he was a part of DAD sponsored project as well. He has published several research papers in reputed journals and conferences. He is also active reviewer for various reputed journals in this field. Good afternoon, sir. We just need your camera to be on, sir, so that we'll take a group picture and you can continue with the FTP.
Okay.
I request all the participants to on your cameras, please. The sessions.
Okay. Okay. Thank you. Thank you for the introduction. Thank you for the opportunity. Um, Let me share my screen. Let me know if it is visible. Okay. Okay. Um, so we'll discuss about the different stages of natural language processing and how to optimize them. And we'll see a bit of application in image caption generation. So at any point of the duration of the presentation, if you have any questions, feel free to ask directly. Fine. Okay. To start with, we'll see uh, the different stages of NLP. First of all, we'll see what. Yes, it's not moving. Network issues will not be. Okay, okay, let me check once. Just check if it is visible now. I have turned up the video. Is it fine enough? No? Okay. Okay, let me present it again. Yes, 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 please. Um, so first of all, very sorry for the interruptions and delay. Fine. Uh, we'll see that what are the different stages of NLP, then how NLP helps in image caption generation. A basic application of NLP is in image caption generation. So we'll be going through that. So can you go to the next slide, please, sir? Next slide. Next slide. Yes. So what do you mean by NLP? NLP is natural language processing, which means how a human interact with a system that is solved by NLP. The system understands only bits and bytes languages, right? So if a system can be made to understand human language, then we have to process through the NLP task. So the basic pipeline starts from text acquisition and pre-processing. First, we have to acquire the text. Based on that, we have then process the text so that you can prepare any NLP tool on that. Fine. Next step. Next, please. Okay. Text cleaning is the first step. When you acquire any text, first thing is to clean the text. Cleaning means you have to uh, remove the punctuation marks, you have to correct any spelling errors, you have to decrease the sentence length and all. So that involves text cleaning. Yeah. Next, please. Go on, go on. Next. Next, please. Yeah. Okay. After you clean the text, the next task is to normalize. Normalizing means you have to prepare the sentences in terms of all either lowercase or uppercase. So mostly the accepted norms is that you prepare all the letters in terms of lowercase. Then you stem. Stem means suppose the word is running, so it is generated from the word run. So instead of run and running together being kept, we should keep only one term, that is run. So that is stemming. So there are multiple algorithms for it. Famous one is protostemmer. Then you have to lematize. Lematize means converting into the base form. Like better is generated from good. So instead of storing good and better both, we used to store only good. So lower casing is the first step. Stemming and limitation is the second step. Next. So how do you represent the text that you have cleaned? Next, please. So the texts are normally represented by tokens. Initially, converted into tokens. Suppose there are some words you cannot directly represent in terms of bits and bytes, right? You have to convert it into some form of token. You have to separate the different words which are combined, like in case of can't. It is actually can and not. Okay. So these words has to be separated out. Unhappiness, these are two words or two tokens, not two words, two tokens. So tokenization is a second phase of the task. Fine. Next. Stopper removal, that's a common process that you don't keep all the words, you remove the stop words. Stop word means which are very common, like a and the articles, the numbers, those are not required to be processed through your corpus, so you remove them. So that is called stop word removal, right? So this is the third step. Okay, next. Then we have TF-IDF, which is term frequency inverse document. It presents any terms present in the document or document with those terms. So utilizing this TF-IDF also, you can convert any copper into vector. Fine. So that is called feature engineering, which lets you convert your corpus or set of sentences into vectors. Fine. Next. Okay. Next. Next step is syntactic and semantic analysis. See. Okay. Go on. Next. Syntactic analysis means you have to analyze the syntax, whether the syntax are correct or not, whether the sentences written before storing, you have to represent whether it in terms of English grammar it is correct or not. So that is syntax analysis. Then semantics means rules. So as per the rules of the language, if the sentences are correct or not, just checked. For that, we need part of speech tagging. POS, we call that post tagging. Post tagging means what is the part of speech of the particular word. So you have to find part of speech for each word present in your corpus, right? There are different methods. We will not go into the details of them, but you can have an idea about part of speech tagging methods. Those are rule based, then random field or hidden Markov model based. Those are statistic tagging, but it's based on so context aware models. So most of the time, for the time being, researchers are using BERT post tagging methods because they are hiding the context of the entirely in what. So that gives you better result. So part of speech tagging is one of the major characteristics of NLP. Yeah. Next. Dependency parsing is again a very important phase where you analyze the dependency between the tokens inside a sentence, inside the sentences. So image is upon so verb going is dependent upon the object. So similarly, analyzing the relationship between the words is also necessary. That is covered under dependency parsing. So there are many freely available tools you can use. Spacey, Stanford Parser, Stanford NLP. So these things fine. Next. Yeah, another important characteristics is name entity recognition, where name entity recognizes that some nouns are in terms of which entity, either it may be person, organization, location, or any other terms, but mostly we recognize them in terms of nouns, NP, noun phrase. Those are also required when you are doing any specific NLP tasks like translation, question answering. In those cases, name entity recognition will help. There are deep learning approach like BiLSTM CRF models are very much useful, but can also come in. Yeah, next. Next. Fine, these are covered. Next. Next. Yeah, these are also feature representation is like this. We can have backup words like we discussed, TF, IDF, what to bake model, Glove, fast text. Then transformer based models are now coming in to represent the features. So yeah, next. Then how do you optimize the feature representation? See, the most important part is the feature generation. When purpose for any NLP task, main thing is that the purpose will be very huge to pre-process to convert them into tokens. Then you have to when you are storing them in vectors, right? Those vectors will be having very huge dimension. The dimension will be very large. So how do you store them? If you store the large dimensional vectors, it will take up more space. Not only space, when you process them, it will take up more parameters, more weight, more time, and more resources. Fine. So we have to optimize the storage. For that, you might know it, PDA principal component. Then there is truncated SVD, using which you can inbuilt the context of the words. So only those words or those vectors components will be stored which are information extensive. Otherwise, others will be dropped. So PCA utilizes this kind of technology, like it converts the entire corpus into or entire sentence, entire number into different axes. On those axes where number of information is more, those will be stored. Otherwise, it will be not stored, which reduces the dimension. So that way you can optimize the features, right? Okay, next. Yeah, next, model optimization. Next part is when you are done with your pre-processing things, you can start preparing the NLP models. So what are the different models in NLP that you normally use? Transformers. Nowadays, attention mechanism based transformers. Previously, it was LSTMs were mostly used. Why? Because LSTMs used to capture the information present in the sentence, but not whole, not the whole amount. Okay, so better attention mechanisms are used. Fine. Next, transfer learning and fine tuning. You can when you are preparing in NLP models are computationally expensive. It takes a lot of amount of time. In some cases, it takes weeks to train any model. It is use if someone else will build and train on your dataset, then refine your model so that you can do your own task, right? That is called transfer learning or fine tuning. Okay, next. Here it is written freeze lower layers. What do you mean by freeze lower layers? Why do you use this freezing of lower layers? Why? Because sometimes in the model, when you know that the lower layers are carrying more information, you don't want to change their weights. In those cases, you freeze their layers. You freeze those layers. If suppose you know that the upper layers, the layers towards the end of the model are carrying more information, then you can freeze those layers so that the parameters won't change. Okay, this is an important concept. Freezing of layers. You can choose which layers to freeze, which layers to unfreeze when you are training the model, right? Okay, next. Once you are done with the model, you can use these methods like model compression and training optimization. You can have you can remove the redundant weights, that is called model pruning. Then you can use this mixed precision training. Why? Because your model will be mostly storing the parameters in terms of, or the weights in terms of floats, floating point values, right? You can use them in terms of FP16, because if it is not FP16, you'll be storing them in terms of FP32. Take up more space. Dropout rate, weight decay. When it is called learning rate, that means how fast you want the model to learn and how slow you want the model to learn. Then batch size is how, what is the size of the input training data that you are sending at a time to the model, that the model sees. The batch size you prefer to be small enough, and in some application prefer moderate amount of batch size, right? It depends upon your application which you are. You can tune these parameters. Now, sometimes you keep very high, sometimes you keep less. So that depends upon your type of application that you are having. Fine. Okay. Next, out limit weight. These are type of parameters that you can set during your training process so that your model learns as per that. Fine. Okay. Next. Once your model is done with the preparation of training process, then if your application wants to have any search strategy, like if you want to search the best result out of the repository, then any such methodologies like search, random. Yeah, these are already we have discussed. Removing noise and irrelevance. How do you remove the stop words, how to remove the spelling errors. There are statistical based models like text blob, which will be correcting your spelling. Suppose in Google when you are writing, it prompts you the near proper word if you are having a spelling mistake in your word. So those correction awareness are present through many statistical technologies, statistical tech, which will be helping you to remove noise, if any, in your corpus. Yeah, yeah. Next, yes, handling imbalanced text data. This is an important phase. Suppose in many cases, suppose you are dealing with low resource languages. Suppose there is a language number of resource number of corpus is very small. The corpus size is very small. It's a low resource language. You don't have much data. Then what you will do? Depending on that, you can use this data augmentation techniques, uh, which one of them is smart, which will be oversampling. That means it can produce more number of samples for your data. If you have this data, produce more number of samples so that your sample increase, which will result in better training of your model. Fine. Then undersampling also is one of the important tasks, which will be suppose imbalanced data is there. Suppose you are doing a classification problem. You are attending to a classification problem where 5 classes are there. Out of that, only three classes are having huge number of data. 2 classes are having very less amount of data. So what you do is that instead of oversampling the two data, you can undersample also the 3 classes which are having huge number of data. You can undersample them. Fine. So both way you can work oversampling or undersampling to handle the imbalanced text data. Fine. Yeah. Next. Feature representation optimization. This is already you have discussed that you can use any kind of dimensionality reduction techniques like your PCA or statistical SBD. So many things are there. You can use word embedding techniques, word to bake, globe. These are very much efficient embedding techniques, which will be generating the embeddings from your given corpus that will be used for that will be used as the feature. Fine. Okay. Next. Yeah. Initially, when we are talking about the features, there are vectors, but what lies the difference is that contextual embeddings produce contextual embeddings again. Apart from embedding, what new is that the context of the word. Suppose he has gone to school today. Okay. So if instead of storing only the school, if along with school you are storing today, so the information about school also accompanies the word today, or in some sense it accompanies the context of the end efficient. Okay, that's the whole aim, contextual embedding, which is very efficiently done by word based techniques, which are bidirectional transformation, will be helping to embed the context bidirectionally. That means from the previous words, from the next words, the contexts will be embedded while you are representing any word in terms of vector and storing in the system. Right. So for that, context embeddings are needed. Okay. Next. Yeah. Model selection and tuning is important to model. Why? Because in terms of NLP, if we say LSMs, RNNs were the starting point, RNNs generated because RNNs were not so in when it came, now they managed to store the information about the previous word orders, but not that efficient. Then came self-attention model, then came transformer models, which very much surpassed the performance of RNNs and LSTMs. They used to perform better than those earlier models. So selecting specific types of model. See, if you have having huge amount of data, LSTMs might be good, a good one. If you are having that be good one, right? It does matter selecting the models for any NLP applications. Next, next, please. Um, yeah, it's fine. Next, evaluation matrix. Once you are done with all the process, all the previous like we saw, model preparation we saw, model optimization we saw, then once the model is done, how do you evaluate the model in terms of NLP? When you are preparing any model, how do you know that your model is fine enough? Suppose English translation, I'm sure that many of you are doing NLP translation related tasks. So how do you evaluate your system? It's always based on maybe blue score you are evaluating or rock score, meter score. So how do they work? So also many techniques are there. You can have your own ROG methods also. You can modify, you can tweak their parameter, you can generate better result out of that. So there are different types of evaluation metrics that you can utilize, right? Okay. So and when you are you can tweaks when minimize so that you can reduce the error rate, reduce the to have better result. Fine. Yeah. Next, please. Yeah, this is fine. Next. Yeah, application is any. I'm sure that you'll be knowing information extraction, information, then setting, experiment, NLP is a area where it is expandable to many of the sub areas, many of the sub applications. So you can choose any one of them for your work or your task. Yeah, fine. Next, we'll go into the details of like what what is language models, how they are helpful. We'll see. Next, first thing is language model. Then comes large language models. Okay, language model means what? A model which generate next word for you. Okay, it is not actually generating the entire language for you. Fine, if you give one word, it will generate the next word. Okay, so where like suppose you write something, it gives you almost the proper answer in many cases. Fine, so how they are generating a very similar result as a human would have generated. So these are based on language models based on huge background of corpus or data based on which they are trained. Okay, so the language models main fact is that they generate the next word given a previous word. Okay? So the key capabilities is text completion, translation, and of course the question answering. Yeah, so they are based on transformer models, as I said, words, or different varieties of words are there. Using them, large language models are very much helpful in nowadays. Okay, core components of large language models, self attention mechanisms. We'll see a bit of self attention mechanism now. They are part of transformer architecture. Then pre-trained if you have specific task of suppose question answering, then you can utilize a large language to prepare a question. You can prepare a machine translation based model. So that's called downstreaming. Okay. Fine. Next. Yeah, this is the basic equation for a LLM, or basically we call it a language model, where you can see P is any predicate, or say it's a sentence, where WT is produced when given W1 to WT minus 1. Okay, so there are previous words based on which it produces a net which is WT. So it any data W1 to WT minus 1, it produces WT. Okay. Okay, next. Yeah, this is a major very important part. I am sure that you all of you might be knowing about this. Self attention mechanism is a mechanism which is used to pay more focused attention to any sentence instead of just storing the sentence in terms of embeddings. Rather, it should be attention based embeddings where you are paying proper attention to each word. You can see here that this attention matrix A is produced from alpha 1, 1, alpha 1, 2, 1, 3, like that. And in the left side of the figure, if you can check, alpha 1, 1, alpha 1, 2, those are produced through various input of QKV. What is this QKV? These are some kind of keys which are based on some equations produced from the input words itself. Okay, based on the input word vector, QKV will be calculated. Again, based on the QKV, you apply this alpha ij formula so that you can generate the alpha 1 2, alpha 1 1, alpha 1 3, like that. Then you combine them in terms of self attention matrix. So fact is that you are not directly storing the words as embedding process, rather you are inbuilding in feeding more context into the words. So that is what self attention mechanism talks about. It carries more importance than your normal embeddings. That is why if you are using self attention mechanism in NLP, if for any kind of task, it will be giving you more accurate or efficient result. Fine. Next. Fine. You can skip this. Go next. Fine tuning, yes, for as any other methods, any other models, fine tunings in LLMs are required. If you are using medical question answering, then you can utilize the corpus of medical domain. If you are using translation based mechanism for any translation based application for any low resource language, then you can utilize your own corpus in low resource language for training the or getting the data out of it. So yes, parameter efficient techniques like LoRa you can use, because once you are using LLM, be sure that you'll be facing a lot of parameters, a lot of weights. So instead of paying attention to all the weights or storing all the weights, you can specifically choose or you can reduce which weights can be ignored. So those techniques are called LoRa or adaptive of LLM to optimize your storage or your training process. Next, next, please. Yes, optimizing LLM deployment. When you are deploying the LLM as a hardware acceleration, instead of GPUs, you can use TPUs. Then you can use for int instead of you can use it in order to convert the weights so that the model will get a bit smaller in terms of while deploying. Fine. Next, highness, hallucinations, compute costs. So compute costs is always present in other modes also. LLM is not a exception. So apart from that, hallucination is a very important part where model tend to generate incorrect text or incorrect result. Hallucinating means it it thinks that I am producing perfect result, but actually it is not. So that is hallucinating. There are multiple ways in terms of stop the hallucination of the LLMs. So this is also one of the budding research area addressing hallucination. Biasness, of course, depending upon the training data, the biasness occurs in many of the field. That has to be handled. Fine. Next. Yeah. Now a small application of NLP where image caption generation comes in. Image caption generation means given image, the system should generate text. Okay, caption, text or caption. Like this, here two figures are given. The captions are generated. That means these are the sentences which are describing the images based on some kind of fine. I am sure many of you, since these many faculties are there, some of you must be working on this also. So I'll just put some light on how image caption generation is a area where you can contribute. Yeah, next please. Next. Next applications are there. Yes, in robotics, in virtual assistants, then describing the figure automatically in Facebook, in social medias, and storytelling. So there are many applications. Not only this is not limited only to specific area. Fine. Next. Okay. So if you are trying to build a system for image caption generation, always remember that there are three aspects to it. One is the encoder, one is the sorry, there are three aspects. One is the input, one is the encoder decoder, third is the output. Okay, so when you are inputting something, what you are inputting image and text. Then you are getting as output is what you are getting as output is text. That means when you are preparing the model, you are showing the model that this is the image, this is the corresponding text. Fine. And when you are utilizing the model for testing, you are passing only the image, it will generate the text for you. Fine. So that's the testing process. So these are the components of a caption generator. Fine. Go next. Yeah, this everyone knows that images are represented in terms of metrics. CNNs are very good at it because those utilizes convolutional process. Here we can see that if it is a gray image, if it is a gray cell, then the number is 0, and if it is a white cell, then it will be 255. Fine. So the range is from 0 to 255. This way we represent the figure in terms of any matrix in a system. Fine. Go next. Then how? What is the convolutional process? We'll see next. You yeah. First is the text representation. Sorry, the image representation that we saw. That images are represented in terms of matrix. Now text will be represented in terms of what? Vectors that we have already seen. Vectors. That is the embedded vectors we call. So the text needs to be converted into vectors. That can be done through any of the embedding techniques. Maybe it is what to bake, maybe it is glove, maybe it is fast text. There are a lot of statistical model now you can utilize. Even Spacey can do that. So continuous bag of words model, skip gram model, those are previous techniques. Those were used. Fine. So using them, you can convert the text into vector. Then you can store them. Next. Next, please. Yeah, globe is one of them. Yeah, we have covered this. Yeah. What is convolutional process? You might be knowing this already. Convolutional is just process of hovering a window over a matrix. The well, which you can choose on your own. Maybe it is for this particular 3 cross 4 matrix, 4 cross 3 matrix. You can have a kernel of 2 cross 2, which rotates around, revolves around the matrix and prepares the convolutional operation. Okay, like the output, you can see that a into w plus b into x plus e into y plus f into x. So these are all part of the convolutional process. Once you prepare the convolution, what is the importance of convolutional process? Yeah, these already you might be knowing. If you are having a character, handwritten character 9, then you can see that how it is presented. Only the edges are well, you can utilize a loopy pattern filter. To this, the filter might be different. So once you are utilizing it, you are getting the convoluted matrix. Then you are using the ReLU. ReLU means it will only the positive from the negative so that your is only complex. Fine. So once you are utilizing the ReLU, then you are utilizing the max pooling. So max pooling means you are keeping suppose a 2 cross 2 window you are keeping here. So in the first 2 cross 2 window you are getting max amount is 0. Sorry 1. In the second window it is 0.33. So in that way you can utilize the max pooling to limit the matrix. Okay, instead of storing the entire 9 as shown in the first matrix, you can see what the last matrix stores. This is the basic CNN process where it is a combination of convolution plus ReLU plus max pooling. Okay, yeah. So this is an example of max pooling. Yeah, you can go next. Go next. Go next. This is a example of basic CNN classification. How CNN classifies a given image. Advantage of CNN, yes, we know that it is better for handling the images. It reduces the size of the matrix to be stored so that your training process gets efficient. Yeah, next. Next, multiple process. We'll see next. Go next. Next, please. If after the you can say as per the activation function, the then you can prepare the activation function such a way that it can the activation function in such a way that the previous state is carried or it may be converted. If you don't want to remember for the state, then it can be made turn to 0. Fine. So through 3 gates, input gate, output gate, and forget gate, the exchange are prepared. Next, bit more detail. Yeah, here you can see that uh, the function fx is a activation function of wf, which is the weight, with the st1. St1 means the previous hidden state with current input, plus bf. Bf is the bias. Fine. So based on that, your fx is prepared, which is current input, previous state, and a bias. Then the next component is uh, the forget gate. The forget gate is normally we call it the CT, which provides the change, which is based on tan h of WC. WC is the weight of this particular weight parameter of this particular state. Then the previous state XT as previous one. It's BC. BC is again the bias for this particular stage. Based on that, we prepare the this component, forget component. So if you wish, you can you can make it 0, so that you don't want this particular stage to carry on to the next state. Yeah. So yeah, approaches to image caption generation, there are multiple approaches. Template based, retrieval based, those are quite old. Now everything is based on deep learning based approaches. So we'll see hints of those things. Go next. Template based method, yes. For template based methods, previously they used to have it prepare a template based on only the subject verb object. Like uh, suppose a figure is there where a person is running, so the caption will be a person is running. Okay, so person is running, so person is the subject, is the running is the verb, object is the person. So subject verb object, we have to prepare the caption in terms of this particular template only. So if it is dependent upon, if it is in a different language, then as per that the template has to be prepared. So this was quite old. We are not using these methods nowadays. So yeah, next. Retrieval based methods are also kind of old, because what they used to do is that they used to prepare repository of embeddings for text, repository of embeddings for images separately. Whichever images and they are saying that this is the caption of that particular image. So that also is an inefficient method. Okay, go next. Yeah, this is an example of retrieval based method, which you can see that a image is compared among the other images through vector comparison, and whichever text matches closely to that image, that will be shown as the caption. But that actually is not proper. Fine. So it came that deep learning techniques are applied. Go next. Deep learning based method, there are many approaches. Some of them we'll see. Go next. 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 The language model we have already covered. It utilizes, it has to have a language model because we are generating the next word given the previous word. You can see that in the orange cell, the first word is uh, the first word is go. That means it's a token only. It symbolizes that the sentence starts from go. Once you show the model the word go, it will generate I. Then when you again produce that output in terms of input, that means I is given as input as the second orange cell, it will produce the next output cell. Green is am. Okay, so I am at home today. Fine. So I am at home today is the output which is generated from go I am at home. So you are training the model based on some previous words. which is generating you the next word. So this is a part of language model itself. Fine. Next, next. No, go to the previous slide once. Previous slide. Yeah. So the encoder decoder architecture works like this. If you see that encoder is the process where you are encoding any image or text in terms of vector, then you are passing that into the language model, so that your language model will ultimately produce the final output, which is the sentence. So you can see that below there is a small image being given, which is converted in terms of some vector through the CNN, because CNN is the model which converts into embedding of the image. That embedding in terms of vector is passed along with the input sentence in terms of orange cells, you can see, so that you are producing in the final result in terms of green cells at the top. Fine. Next. Next. Next, please. Okay. This is a basic representation of CNN RSTM based architecture, where the input is two things you can see. One is the left side is the image. Below, in the purple cell, that is start, giraffes, up to other. So words are given, sentences are converted into tokens. Those tokens are given in terms of embeddings into the LSTM. Fine. So ultimately, it produces the final output in terms of caption at the top. Okay. So this is a basic schematic representation of how a CNN LSTM based encoder decoder architecture works for producing image captions. Fine. Go next. So you can have additional inputs to the model also. Like in the previous case, we saw that we are giving input, which is the image embedding and text embedding. Along with that, you can also additionally input some other forms of data, like topic about the sentence that you have inputted. Suppose the sentence is related to cooking, so you can add the topic of the sentence like utensils or cooking material, so that your output result will be more inclined towards producing cooking related sentences. Fine. So uh, in the left side you can see that image topic can be extracted through any LDA method that will be passed as additional input. Then these things are common. The encoder decoder architecture are same as previous, and you can have better result. You can see in the next slide. Next slide. Yeah, this is a description of what LDA is. So LDA is something which will be predicting a approximate topic of your sentence. Okay, so image along with the text along with the topic will be the three inputs which you can input to the model, and it will be more efficient in terms of generating the result. Fine. So you are not only limited to image and text, rather you can have additional input to the model as per your application domain, so that the result will be further improved. Go next. 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 Yeah, here you can see the difference between uh, a original caption in the dataset and a system generated caption. So it is almost similar. If you can see, these are almost similar. So in many cases this won't be same. In many cases this will be better. In many cases this will be less good. Fine. So go next. So this is all through the topic based model. if you can utilize the attention model that you have already discussed, attention based model will focus on the particular image component along with the text component, so that the result in terms of text will be produced keeping in mind what it is seeing, what type of text it is seeing, and what type of image component it is seeing. So it pays attention to particular part of the input. Fine. Go next. Next. Yeah, this is fine. This is the attention mechanism through which it pays attention, as we have seen before, that it is the so based on Q, K, and V, three keys that you have to generate from the words. Based on that, and utilizing this alpha through this particular equation, your particular matrix component for the images will be generated. Images will be generated, so that that will be carrying context of the text, context of the image, in order to produce the final result. Fine. So attention based models are, that's why, very much useful. So that is the reason why transformer models are working more efficiently nowadays. Instead of utilizing just encoder decoder based mechanism, if you can utilize transformer based mechanisms, your result will be far better. Okay, go next. So that there are different types of attention. Yes, you can see them. Go next. Additive attention, location based attention, and all. Fine. So this is the way you might be, you might have seen this famous paper on show, attend, and tell. This speaks clearly how attention mechanism is beneficial. When you are under the word frisbee, it actually focuses on that equivalent component of the image. You can see the white dot in the image. It is actually generated through the machine. The moment you are seeing the text which is underlined, it focuses on the same similar type of feature in the image, right? So it learns that which component represents which text. So that is why the end result will be far better when you are utilizing attention mechanisms. Go next. Finally, you have many data sets which you can start with. We always prefer to work with small data set initially. So you can go with Flickr. Microsoft Coco is MS Coco is a very huge data set which has 80 object categories. Each category has 5 captions. So you can imagine that it's a huge one. You have MS Coco 2011, 2017. So there are different versions of the data set. But to start with, we always start with Flickr 8K or Flickr 16K dataset, because these are limited. Your model will not be that complex. Go next. Yeah, this, as I said, 8K, 16K, 30K. So the limited images are there. Your model will be very smooth. Your learning process will be smooth. Then once you are fine with this, you can opt for the MS Coco. Evaluation matrix, yeah, we have already covered. For this type of task, mostly we use Blue, which is again the same as translation, because this is image caption is actually nothing but a type of translation only. You are translating, suppose, from English to Urdu or English to Telugu. Here you are translating one image to one English sentence. So this is same translation only, a vector to vector. So Blue is the most preferred form of evaluation. Then you have, as usual, slider, spice, meter, rock, scores. So this can be used. Fine. Next. Next, please. Yeah, based on this, we can say that there are multiple research directions opting out of this multimodal summarization, where you have to handle both image and text and produce the summary, because summarization is a very hot topic now in case of NLP. Then social media post analysis, instead of going one by one, you can directly feed any social media handle, and you can analyze all the posts and how, why, where it leads. You can accumulate the knowledge. Then navigation techniques, visual question answering. These are all part of NLP, which can be done through this kind of models. Yeah, next. More or less, this is the presentation. Yeah, go next. Yeah, thank you. If anyone has any question, feel free to ask anywhere from the talk. Next, my email ID is there. If anyone wants to uh, mail or ask any questions through mail or suggestions through mail, then it's very much welcome. Yeah, fine. This is already done. Yes,
Sir,
yes.
participants, do you have any queries? You can please ask now. Have any queries? You can place it in the chat box also.
Yeah, feel free to ask because however, that was beyond my control. So, if any doubt still, you can write in the text chat box, or you can mail me directly, or you can have the number. You can WhatsApp any questions and all, any research uh, directions, etc. We can discuss at a length whenever you want.
Okay, participants, if you don't have any questions or queries, we can wind up the session. Okay, then. Okay, then. Thank you, sir. Thank you, Sandeep, sir, for your expertise, for your knowledgeable presentation. Even if we have some disturbances in the net through the network, so we are glad to have you here, sir. We look forward to have more sessions with you in the future. Thank you so much, sir.
Thank you so much. Thank you to the organizations for inviting. Thank you.
We have seen it's very privileged to have you with us. Thank you so much.